And so here is question 2a, and what it's asking us to do is try and find a value of a that is going to make this function continuous, and if no such value exists, just explain why that is. Okay, so this is just the classic removable discontinuity problem. We can factor the top of this equation into x plus 2 times x minus 2 over x plus 2. Basically, we have a repeated factor in the top and bottom, and so we can cancel these guys out like that. We have to make that noise when we do it. And this is basically the equivalent function. It's actually just x minus 2. In other words, it's just a linear function with the exception that x cannot be equal to negative 2. So we have a removable discontinuity when x is equal to negative 2. Now, if we check the limits from below and the limits from above, we find that they are both equal to negative 4. And we just do that because we can just substitute negative 2 for x into what the function is. So above and below, the limit is the same, and so what we have is a removable discontinuity. So we can actually just say, you know what, this function is x squared minus 4 divided by x plus 2 if x is not equal to negative 2, and it's negative 4 if x is equal to negative 2, and that would fill that function in completely, and we wouldn't have to worry about any bumps in the function. Unfortunately, I think that was a typo in the function, in the actual question, because it was talking about can you give it a value of a when x is equal to positive 2? And the answer would be no, you're not going to make it continuous because you can't redefine the function at x is equal to positive 2 and fill in the hole. And so if you didn't see me do this earlier, actually this is this is the actual function right here, x squared minus 4 over x plus 2. And when we plot it in Desmos, you can see that Desmos, of course, knows that those cancel out, and it just makes a linear function. And as we drag our point along here, when we get to x equals, I did that before, x equals negative 2, we can see this thing is undefined. That's basically the hole that we're filling in. So Desmos is telling us what we did algebraically. You need to be able to do it algebraically.